A confirmation regarding the audio, please, guys. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. Okay. So, hello, a very warm good evening to all of you, and welcome to Byju's Exam Prep. Welcome to another session of climatology, where today we shall be building upon the concepts that we studied yesterday. So, yesterday we had taken a look at the factors of pressure. We had also understood why is it that winds move from point A to point B in any particular part of the world. And there are various different factors which end up influencing the movement of the wind, the direction that the wind takes, the velocity that the wind attains. And those factors also we have studied in significantly greater detail. Now, after that we took a look at the portion of permanent winds. What are the permanent winds? That is the polar easterlies, the westerlies, and the northeasterlies, or the trade winds. These are the permanent winds, and we have the associated pressure zones as well. That is the equatorial low or the ITCZ. Then you have the subtropical highs, the subpolar low, and the polar highs. Now, all these pressure belts, other than the polar high, all these pressure belts, they end up shifting with the change in seasons that is experienced in various different parts. Then we had initiated a discussion for the local winds. What do we understand by the local winds? So these are the winds which exist only for a shorter region and also for a smaller duration. Maybe on a daily basis, you have the occurrence of the winds in a small area, or maybe we observe the seasonal existence of these winds. So the daily local winds that we have seen the existence of land breeze and sea breeze, as well as mountain breeze and valley breeze. Now, today, we are going to take a look into few of the other local winds that are seasonal and move in different parts of the world. And along with that, I will be giving you the listed local winds which shall be relevant for your prelims examination, which you can go across for your prelims. And after this, we shall be initiating the discussion for what do we mean by humidity, what is precipitation, and those factors we are going to initiate a discussion about. Okay, so yesterday we had taken a look at Lu. We had seen that Lu basically is a warm advection, is a local wind which is generated and blows from west to east in the northern part of the country, especially during the afternoon. And that is when they increase the temperature to almost 45 degrees Celsius in certain cases. Now, why is it that Lu becomes so warm and dry? Because as it moves from west to east, it becomes dry as it passes through the region of the Thar Desert. And during the month of May and June, Lu, or rather the Thar Desert, is automatically and extraordinarily hot. And that is where the wind becomes warmer and the wind becomes drier as well. Then we take a look into the Chinook. Chinook, also a local wind, a seasonal local wind which is in existence. Now, Chinooks, they are also referred to as snow eaters because in the region that they blow, there they end up melting the snow in that region. They facilitate the melting of snow in that region, and hence they are referred to as snow eaters. So, where is it that we observe the movement of Chinook? So Chinook is observed in the case of the eastern part of Rocky Mountains. Now, in which continent do we have the Rocky Mountains? In which region of the earth do we have the Rocky Mountains? Good. It is in the western part of North America, some portions in United States, some portions in Canada. Now there, if you consider this, let's suppose you consider the western edge of North America. This is where you will have your Rockies. Okay. Now these Rockies, they will have a western slope, as well as an eastern slope. So if you were to imagine the movement of it, you have to understand that if you consider the cross section of, let's suppose, the Rocky Mountains. Okay. Now this is your western slope. And this is your eastern slope. Now, for any mountain, the side or the slope which faces the wind directly, that is referred to as the windward side. For any mountain, the side or the slope which faces the direct oncoming wind, that is the windward side. So in this case, if the winds are approaching from here, they are going to hit the western slope directly, isn't it? So the western slope in this case becomes the windward side of the Rockies. The side of the mountain which is opposite to the direction of oncoming wind, that is referred to as leeward side, right? So this will be the leeward side. Now here, as the winds will approach the western slope, these winds, they shall start rising up. In fact, they shall be pushed up. Now, as they are pushed up, what will happen to the wind? In terms of their temperature, as the wind starts rising up, what is observed in the case of temperature? What do you think? Very good. So when the wind rises up, it tends to expand and the temperature reduces. So the wind cools down. Whatever moisture, whatever water vapor would be present, as the temperature decreases, those moisture and those vapor, they will form clouds and they can lead to causation of rainfall. Rainfall will be observed on which side of the mountain? Always on the windward side, you will experience the rainfall to be coming. Now, the wind which has caused the rainfall and the wind which has reached here. So this wind, can we not say, because all the water vapor which was present, all the water vapor due to reduction in temperature got condensed into clouds and led to the causation of rainfall. So this wind is now dry. Right? This wind is now dry, which is on top of the mountain. Now this wind automatically will come down the slope along the leeward side, isn't it? So as it comes down the slope, what will happen to the wind movement and the property of the wind? It is going to move into an area where the wind density is already very high, isn't it? That is where it will go into. So there the wind density is already very high. So what do you experience the wind to undergo? Very good. Beautiful. So it will lead to the wind undergoes compression and adiabatic heating. So basically, this wind which is moving on the leeward side, that is now dry as well, because all the rainfall was extracted in the windward side itself. So this wind is dry, At the same time, due to compression and adiabatic heating, there is a warming up of this wind as well. The wind warms up as well. Its temperature increases. Now, because of these properties that the wind gains, by the time that it reaches the lower portions of the Rockies, its temperature increases to an extent that it causes the melting of snow in the lower areas. In these areas, you will experience melting of snow. Melting of snow. So, because these winds lead to the melting of snow in that part, that is why these winds are referred to as snow eaters. Okay? So, this portion of the wind on the eastern part of the Rockies, that is the eastern part of the Rockies, these winds are referred to as Chinook. Okay? Now, when I say it warms up enough to cause melting, please understand that the temperature of the wind still is not very hot. The wind still might be at a temperature range of around 4 degrees, 5 degrees Celsius, and even that can initiate the melting of the snow, right? So it is not that this wind is going to be very, very hot, but in comparison, when you talk about the characteristics of the wind, this wind is warm and dry. Why? Because it is moving from the leeward side, right? Yes, Neil. Chinook is experienced only in the Rockies, and that too in the eastern part of the Rockies, because on the western part of the Rockies, the same winds will exhibit different characteristic. On the western part, these same winds will cause rainfall. They are not going to be dry winds. It is when they cross over, that is when, because they have led to all the raindrops happening on the windward side, that is why the wind will be left as dry. What if it comes from east side? Why will it come from east side, Arjun? It is not as if tomorrow wind will decide that today north side looks good for me, so let's approach from north side. It is in this region that in certain seasons you find the existence of westerlies which are very strong. So these westerlies, they approach the western coast of North America, they climb over the western part of the Rocky Mountains, and then they start subsiding on the other end. And that is why you have the occurrence of Chinook. It is not observed in India. Local winds, please understand, local winds are observed only in some parts of the world. Loo, do you think Loo is experienced across the entirety of the world just because we observe it in India? I hope nobody is under the misconception that Loo, just because in summer season we experience Loo, so the entire world should experience Loo. I hope that is not the misconception. Loo is very much an Indian phenomena. Chinook, like that, is very much a North American, West North American phenomena. You will not experience Chinook even in eastern part of North America, even in India, right? Nowhere else. Similarly, the next local wind that we are going to refer to, it is restricted only in that particular portion. Okay, so that is why they are called local winds. Okay, in UP, how Chinook is observed? Chinook is present, my dear friend, only in north. See the name Chinook. How many of us we have no clue what the name Chinook means? Please let me know. Yes, it is a helicopter. Helicopter has been named after what? So that helicopter, which has been imported from United States, that with the name Chinook, that has been named after a local Indian tribe in that region. Okay, that is how you have the name Chinook. That tribe's name is Chinook. So in United States military particularly, you will see that all the major air gunships which are there, including all the helicopters, they are all named after tribes. So same is the case of Chinook. So it is by the name of that tribe that this wind is also named. So that is why this is something which is restricted only in that particular portion. Okay. Now, here again, I will repeat it. Listen to this carefully. When we say Chinook, Chinook is a local wind, and this is in existence on the eastern side of the Rocky Mountains. That is where this Chinook comes into existence. Why it comes into existence is because when you have winds blowing across the Rockies, the winds, when they are actually facing the Rockies, the windward side, that is where the winds will be forced to rise up. And when the winds are forced to rise up, their temperature reduces, they cool down. There is condensation of the water vapor which takes place, leading to formation of clouds, causation of rainfall on the windward side. And then the wind which is generated after that, or which is left after that, that is a wind which is dry now because all the moisture has been taken as rainfall. So that is the wind which is dry. Now this wind then comes down the slope. So as the wind is moving down the slope of any particular mountain, as the wind is moving down the slope of a mountain, can we not say it is moving into an area where the air density is going to be very high? So for the wind to accommodate itself and still further pursue the movement downwards, the wind will have to compress itself, right? So that is why the wind undergoes a kind of an adiabatic heating that we studied earlier. So that adiabatic heating raises the temperature of the wind, and this wind is already dry. So that is what leads to the melting of the snow across the eastern part of the Rockies, and that is why these winds are referred to as snow eaters as well. Okay. Now, then we have another local wind in the region of Europe, that is Foehn. Now, Foehn also has got a very, very similar characteristic to Chinook. The difference is that it blows in the region of Europe, and also the difference is rather than the Rockies, here you have the Alps. It blows across the Alps. So it is also warm and dry wind like Chinook, and here it moves across the Alps mountains. Now, because the alignment of the Alps is such, Alps will not have a western or a eastern slope. Alps will have a southern slope, just like the case of Himalayas, southern slope, and also northern slope. It has got a northern slope and a southern slope. So here the winds approach, in the case of the Alps, to the southern slope. And if you analyze this again, this is, let's say, your southern slope. Now, in this case, because the winds are coming from the direction and hitting the southern slopes, so that is why the southern slopes will be the windward side in this case. This will be the windward side. Now, the winds, when they approach this mountain, they will face an obstruction. So they will be forced to rise up. Now, when the winds are forced to rise up, what happens to the wind temperature? As the air rises up, what happens to its temperature? Beautiful, Pranay. Wonderful, my dear friend. So, yes, it becomes low. It cools down, right? Adiabatic expansion and cooling that happens. So, in this region, as the wind rises up, it cools down. It tends to become colder and colder. Now, whatever moisture or water vapor is present in the wind, upon cooling down, what will happen to water vapor? Water vapor, if you cool it down, it gets converted into liquid water droplets, isn't it? So here it will get converted into clouds, will cause rainfall on this side, windward side. And now the wind that is left, this wind, we can say that this wind is dry. Now it is dry. Why? Because whatever water vapor was present, that has been used in the windward side itself. So now that this wind is dry and it is on the top, it will eventually come down. It will come down aided by the gravitational pull as well. Now, as this wind is basically going to come down, can we not say that this wind is going to encounter an area where suddenly the air density is going to be very high? Isn't it? It is coming from top of the mountain. At the top of the mountain, the density is less. As you go to the lower region, closer to the surface, the sea level, the air density is more. So the wind is coming into the region of greater air density. So the wind has to accommodate itself somehow to fit there. So that is where the wind will undergo what? It will undergo adiabatic compression or adiabatic heating, just like Chinook. Okay, and as it comes down, that is where it will cause the warming, and that is where in the eastern or rather the northern slope of the Alps, northern slopes of the Alps will experience slight warming. Otherwise, the winters are very harsh. Otherwise, the conditions can be very, very harsh. As they come and become dry and warm, that is what creates a pleasant weather. So basically, here also, the weather becomes quite pleasant in the valleys due to melting of the snow. That is why the valleys of Switzerland, because they receive this kind of a warming which makes the weather conditions very moderate, that is why the valleys of Switzerland are called climatic oases during the winter season. They are referred to as climatic oasis during the winter season. So these winds help in early sowing of wheat, ripening of grapes, and also prevent the formation of frost, right? Prevent the formation of autumn frost, which happens. Okay. Bhavani, in this case of the Rockies, we have seen the western slope and the eastern slope. In the case of the Andes, we have seen the northern slope and the southern slope. Why? Because all the mountains, they don't have the same alignment, is it? When you take the case of Himalayas, what is the eastern and the western slope in this case? You will have a northern slope, you will have a southern slope. If you take the case of conversely, if let's say you consider Andes as a mountain, Andes as a mountain range, the axis is somewhat like this. What will be the northern and southern slope? There won't be any. So here you will have western and the eastern slope. So depending upon the axis and the alignment of the mountain range, that is how you have the slopes. Suraj, why the dry wind coming down? Where else would it go? Do, it is dry, it is not warm. At the top of the mountain, it is not warm. If the wind had been warm here, then it would have risen up. But it is dry. But it is at higher altitude, so it is slightly colder. And that is why it starts coming down. Okay, Suraj, I hope that is clear now. Chinook moves from high pressure to low pressure. Devansh, all the winds will move only from high pressure to low pressure. All the winds, any kind of winds will always move only from high pressure to low pressure. Okay. Temperature effect on both the slopes of these winds. So basically on the southern slope, Pratyaksh, you will receive rainfall. it might make the winter slightly more or the conditions slightly colder, but on the northern slope it makes it very warm, and that is when you have the very lush green valleys of Switzerland. They blossom. So that is the conditions created by phone. Yes, Priyanka, that is true. Is it due to the collision of the plates? That's why their slopes are shaped like, yes, that is true, Mohammed. Climatic oasis. What is an oasis? I hope we are able to understand what is the term oasis. So, oasis, as most of you would know, that in desert areas, you have small areas in the vast sandy desert where there is absolutely nothing. In certain places, you have small areas or small pools of water. They are referred to as oases. So, oasis basically signify a kind of a relief, a kind of a welcome change. That is the significance or the implication of an oasis. So, when we say climatic oasis, so when the entire region is experiencing very harsh conditions because of phone, the northern slope of Alps, they experience slightly moderating conditions, and that is why climatic oasis. Okay, right? Now, then we have another local wind in the region of Europe, and that is named as Mistral. Now, Mistral blows particularly during the winter season in the western part of southwestern part of Europe near the Iberian Peninsula. This is the Iberian Peninsula, the region of Portugal, Spain, some portions of France. That is the region which we refer to as Iberian Peninsula in Europe. So it is through this area, slightly to the northeast of it, that is where the Mistral is in movement. It is again a local wind, and it is generated only during the winter season. Why it is generated? One of the prime reasons for generation of Mistral is, first of all, during winter season, during winter season, if you think about the European land, right, this particular portion, and observe on the map very carefully. Once you understand this, you will be able to retain it for a very long time. So try to understand it rather than finding points to memorize. Try to understand this now. During winter season, if I give you two areas, one is the landmass of Europe and other is the region of the Mediterranean Sea. And this is the region of land over Europe. Now, during winter season, out of the land and the Mediterranean Sea, and I want all of you to give me an answer here. Not participating in this is not an option because that is when we learn, guys. So please don't be afraid to commit mistakes. So during winter season, out of the land and the Mediterranean Sea, which is going to be colder? Is it going to be the land or the Mediterranean Sea, which is going to be the colder one? Very good. Almost unanimously, other than a couple of you, almost unanimously, everyone agrees that it is the land which is going to get colder during the winter season. So, land is colder. What about the region of Mediterranean? Comparatively warmer, right? So, Mediterranean is comparatively warmer. Now, land is colder, Mediterranean is warmer. So, there will be the formation of a kind of a pressure gradient, isn't it? There can be a relative comparative pressure development. So, in comparison to the Mediterranean Sea, land which is colder will develop a kind of a high pressure. Mediterranean, which is comparatively warmer, will develop a kind of a low pressure, isn't it? Winds will blow from a high to a low. So the winds will move from land to the water, and land is colder. So what will be the nature of the wind? Wind will be very cold. So the nature of the wind is it will be very cold. That local wind, which is generated only during the winter in this part of Europe, that is referred to as a mistral. Okay. Now, Mistral is a cold local wind which blows in Spain and France from northwest to southeast. These winds are more common and effective during the winter season because of development of high pressure over Europe and comparative low pressure over the Mediterranean Sea. The arrival of Mistral, because it is very cold, causes sudden drop in air temperature to below freezing point in many areas of Europe. So that is where they bring the cold conditions from one region to other, and they influence the weather climate in the other portions of Europe as well. Okay. Now, another local wind, this again comes into existence in the northern part of North America, also in portions of Siberia, that is the northern portion of Russia, that is blizzard. Blizzard is a very cold polar wind. It is generated from the high pressure in the polar region. That is where the blizzards sometimes are generated from. So these are in a way very, very cold polar winds by their very existence. Now, why they are generated, especially in the northern part or in the northern hemisphere? If you consider the winter season, in the winter season, yes, every region is cold, but comparatively, the regions which are at higher latitude, that is northern Canada, northern part of Europe in certain areas, and northern Siberia in the case of Asia, all these will be comparatively much colder than the correspondingly southern portions. They will be much, much colder. That is where they will develop a localized high pressure, and that is where the winds will start to move. And these winds, when they move, so for example, I consider North America, right? So you have winds coming from the north in this. And northern Canada, northern Siberia, we do know that they will have a lot of snow and ice during the winter season. Now, these winds, when they blow at a speed of around 80 to 100 kilometers per hour. But when they will blow, they will pick up the snow along with them. And suddenly the visibility drops. Not only does the visibility drop because of the huge amount of snow that is being carried, but also the temperature drops because they are bringing cold conditions. So these local conditions are referred to, or these local winds are blizzard. So it is a violent, stormy, cold and powdery polar wind which is laden with dry snow and is prevalent in south polar regions, Siberia, Canada, and also the United States. Okay. Now, the visibility becomes remarkably low because of the snow that this wind is able to carry, and velocity oftentimes ranges between around 80 to 100 kilometer per hour overall. That is the variation in velocity. Now, arrival of these winds causes sudden drop in the air temperature, and the visibility also reduces, brings about a lot of cold waves. Many people, they lose their life when they get stuck outside of their houses when you have the blizzard. Last year, we had a very sad case where uh, an Indian family was actually trying to migrate and trying to illegally enter into the United States from the border of Canada. And that is when, while moving in the wilderness, and they lost track, and basically that is when a blizzard struck. And very soon after, their frozen remains were found because the temperature dropped so suddenly that there is a fear of exposure to, or rather, death caused by freezing due to exposure to these winds. So, exposure to these winds will suddenly lead to a drastic reduction in temperature, which can immediately lead to freezing of the body. So, that is where blizzard claims many lives in these areas, right? Yes, hypothermia kicks in. Now, this blizzard ideally would not come into lower latitudes around United States. Before I get into this, how many of us present here are honest enough to, when I ask that, how many of you have not done the map pointing for the mountainous areas? Please be honest and tell me how many of you have not done the map pointing for the mountainous areas. Okay. Okay. So, all those who have done it, you would be aware about the mountain systems which are present in North America. Those who have not done, kindly look at the physical map of North America after the session. You will benefit significantly. That is how geomorphology, what we have studied in geomorphology, if you are good at that, if you try to understand that, if you begin to visualize that, okay, this is where a mountain is, this is how a mountain is created, that is why here you have this mountain, here you have this mountain, then understanding the climatic realities of the place becomes very easy. So, all those who have not looked at the map previously, kindly look at the map after the session. If you observe the map of North America, you will observe that you have two mountain ranges, large mountain ranges, both of them in the north-south alignment. The one across the west, that is where you have a series of various ranges, including the Rockies, right? Here you have Rockies, you have the Cascade Ranges, and so on and so forth. On the eastern side of North America, you will observe the presence of very old fold mountain. What is the name of that? Beautiful. You have the Appalachian. Appalachian, right? So these are the mountain systems present in North America. All of them have a north-south alignment. You don't have an east-west alignment of the mountain like you have in the case of India, where the Himalayas, they create a border, or they create a kind of a frontier from west to east. Here in North America, you don't have anything like that. So when the cold polar winds, they are driven from north, there is nothing stopping these cold polar winds, and that is when they enter into the region of United States. And that is why, despite being in the middle latitude, United States gets influenced by blizzard. Okay, that is the reasoning for it, that US, despite being in middle latitude, gets impacted with blizzard. And the reason being lack of any west to east or east to west mountain range to the north. Okay, that is why. So that is why we have the blizzard being able to impact even the region of United States. Canadian Shield, Sahil, Canadian Shield is to the north. Canadian Shield is something you will find here. Rockies extend furthermore. This is where you will find, and it is not a mountain system, Sahil. It is a kind of a plain, plateau area, featureless almost. That is where in the shield you have the famous 5 lakes which are there. Okay. Right. Now we come to another portion, that is, or another wind, that is Sirocco. So when we talk about Sirocco, Sirocco is a unique wind system which brings about rainfall in the southern coast of Europe. So this is a wind system which originates in the portion of North Africa, crosses the Mediterranean, and then reaches the southern Europe. So originates over North America, crosses the Mediterranean, reaches southern Europe. Now, when this wind originates over the region of North America, read the text later on, guys. Right now, just listen to the aspect of it and the concept of it. When it originates over the region of North America, will it have moisture at that point of time? What do you think? Oh, I have written North America. Thanks for pointing out. It is North Africa. Apologies, guys. So, when this originates over the region of North Africa, then will it be having moisture? No. So, it will be dry. In northern portion of Africa, you have the presence of large desert. You will have the presence of red soil. You have the features such as regs, hamadas, etc. So you have lot of red soil and desert soil which is present. So this wind, as it is originating from there, it will pick up that sand, the sand of the desert, because there is no obstruction that the wind experiences. So it will pick up sand, picks up sand. Then it crosses the region of Mediterranean. While crossing through the region of Mediterranean, will it pick up moisture or not? What do you think? A dry wind moving over the region of Mediterranean, will it be able to pick up moisture? Absolutely yes, it will pick up moisture. So earlier it had only the presence of sand. Now it has got the presence of moisture as well. Then when it is going to reach the region of southern Europe, this is going to be an offshore wind or an onshore wind? What do you think? This is going to be onshore. When it reaches southern Europe, it is an onshore wind. Onshore wind brings what? Rainfall because of the moisture that it is carrying. But along with the moisture, this wind is carrying reddish sand as well. So the raindrops that happen, they will include some particles of that sand as well. Due to which, many of the areas, the raindrop develops a very unique reddish coloration pattern. And that is what gives the appearance that it is red raindrops, and this phenomena of rainfall which is caused by this is referred to as blood rain. Okay, so Sirocco basically is a warm, dry and dusty, full of sands. Now these sands are picked up from the northern portion of Africa. So warm, dry and dusty local wind which blows in the northerly direction from Sahara Desert, and after crossing over the Mediterranean Sea reaches Italy, Spain and so on. Now Sirocco, while passing over the Mediterranean Sea, picks up moisture and brings rainfall in southern part of the Italy or the Italian coastline, where upon the arrival of the rain it is referred to as blood rain, because you have sand which is mixed with the raindrops. So that is what it is referred to, and that is what it leads to. So these are few of the areas and the few of the local winds. Here, all that you have to look into is in which region they exist and their nature. So for that, you will have the list as well, right? So North American local winds, here is the list: Chinook, Blizzard, Santa Ana, and Norte. Then South American local winds, then you have African local winds, then you have European local winds, then you have Asian and Australian local winds. All these local winds, basically, just take a look at it from your prelims perspective and get an idea about where these winds move, whether they are warm or cold. That idea, if it is there, more than sufficient for that particular portion. Okay. Siddhant, we had talked about yesterday about the Indian local wind, that is Lu. That is what we started the discussion from, right? Now we come to the portion of humidity and precipitation. So, humidity and precipitation, when we refer to, so in this portion, we are going to study the portions of humidity. That is, what do we mean by humidity? What is the relation of humidity with temperature? That is, with the change of temperature, whether there is any change in the humidity which is experienced or not. Then, after that, we are going to take a look into, so first of all, we are going to take a look into humidity, the types. Then, after that, we are going to look into condensation. In condensation, we are going to take a look at the formation of dew and also cloud formation. Then associated features of thunder and lightning. Then after that, types of clouds. Then after that, we are going to look into types of rainfall. Fog and mist. And in this, types of fog. So this is going to be our coverage for this particular chapter. Here again, in this chapter, we are going to deal with a lot of basic concepts. Okay. A lot of basic concepts is something we are going to deal with, and we are going to basically try to understand why is it that we observe rainfall or experience rainfall in an area. What are the factors or the features that lead to the causation and occurrence of rainfall? So all those factors, what are the types of fog, why condensation happens, how cloud is created, how lightning occurs, and we are also going to take a look into few of the associated features such as cloud bursts and hailstorms. Cloudbursts and hailstorms. Now, most of it, almost the entirety of the portion that we are going to take a look into, almost the entirety of it is relevant for your prelims perspective. For the mains perspective, you'll find that cloudbursts and hailstorms these are going to be important and relevant. That is going to be important and relevant for your mains examination. Rest all of them, they are going to be relevant for your prelims perspective. Okay, so let us take a look into the straight away the portion of humidity. So when we say humidity, humidity is what? It is the amount of water vapor or moisture which is present in the air surrounding us. That is what is referred to as humidity. Now, water vapor is also a major constituent of the atmosphere, and we have seen that majority of the water vapor is concentrated up till a height of only 5 kilometers from the ground surface. Isn't it? Only up till around 5 kilometers from the ground surface, you'll have majority of the water vapor. Not that above that water vapor is absent, but it is present in very minuscule quantities. So air in different places will have different amount of water vapor which is present. In fact, air in the same place also, in many of the cases, when you consider the air in the same place, there also, in between different times of the day, you experience different amount of water vapor which is present. So the amount of water vapor present in a parcel of air which has a definite volume and temperature, that is referred to as water vapor. So out of A and B, let us assume that the small dots represent the presence of water vapor. Obviously, in B, you have greater concentration of water vapor. So we can always say that B will have higher humidity. Higher humidity. So it is this humidity which renders a kind of a what we say moisture in the air. How much moisture is present in the air? It is basically carried out or observed with the work of humidity. Now, this humidity is again the amount of water vapor present in an air parcel is again dependent on many conditions. For example, if you consider two particular areas, let's suppose one you consider, let's say Goa, another you consider, let's say Jaisalmer. Now, Goa is a coastal area. You will have the presence of sea nearby. So, the air in this region will have higher humidity. Coastal air will be present, and coastal air will have higher humidity. Whereas when we talk about Jaisalmer, it is a drier area, desert region. So that is where here you will have the air, which means this will be dry. So it will have a lesser amount of humidity. So that is how you have the factor of humidity which is determined based upon the factor that what is the amount of water vapor present in any particular area. Now this humidity that we observe in the parcel of air, that is something which can change, which gets influenced by the variation and the impact of temperature as well. How? Let us try to understand. So, for example, when we consider any air parcel, let's assume, when we consider any air parcel, this air parcel will have the presence of various different molecules in them, air particles, etc., dust particles, various different molecules will be present in the air here, right? Now, if I were to say water vapor, now water vapor, where will it accommodate itself? Especially in the spacings which are available between the particles, that is where the water vapor molecule or the gaseous molecule of water, that is where it will be able to accommodate itself. So that is where the gaseous particles of water, you'll find they will accommodate themselves here. So depending upon the spacing available, the water molecules, they are able to adjust, isn't it? Now, suppose if we change the spacing available between the molecules, that means we can be able to change the capacity of the air to carry water. I repeat. So when we talk about the water vapor, all this water vapor is trapped where? In between the air molecules which are present, in between the spacing of them. That is where you have it. So if I give you two different samples of air, one is the earlier one which we have just seen. Let's take another sample of air. And here let's assume that this is the air molecules. This is the air molecules which are present. Now, if you compare both the air samples, the one drawn above and the one that is being drawn now, if you compare both of them, you'll find that in one of them, the spacing available between the molecules is much greater. The spacing is much greater. Higher spacing. Higher spacing means that the air can accommodate more amount of water vapor. When I consider or give you the second sample, you'll find that there is lesser spacing between the particles. Lesser spacing, right? So this air parcel will have less capacity to carry moisture, isn't it? So what if I warm an air parcel? What if I significantly heat up an air parcel? Let's suppose I heat it up. Now, when I provide heat, what happens to the spacing available? The spacings will significantly increase because the particles, the air particles, they will experience a kind of a motion. They will observe a motion. So the spacing has increased. So can we not say that the moisture carrying capacity of the air that has increased? We can say so because now it can accommodate more water vapor. So by heating, we have the warm air, and we can say that the moisture carrying capacity increases. How much moisture is present or not present, that is a factor which is dependent upon whether you have water source near the ground level, what is the movement of wind, etc. There are multiple factors. But then the capacity, whether they have the capacity or not, right? For example, take the case of all of us individuals. Each of us, we have our different capacity. When even if you study for the examination, for the civil services examination, all of you, even though you are attending the same lectures, even though you are reading the same books, you have, many of you have very different capacities. Few of you, you are able to absorb more. Few of you are able to absorb less. Few of you are not able to absorb anything. So it depends. But then let's suppose someone who has a capacity to absorb everything, all the subjects which are happening. Now that is that person's capacity. Whether with that capacity that person reads the subject or does not read the subject, that is his or her prerogative. But then they have that capacity. Similarly, what is the moisture present in the air? That is dependent on the air where it is present, where you have the presence of vapor or the water source, etc., to supply that vapor. It is dependent on that. But the capacity of the air, what is its capacity to store the moisture, that is altered by heating. When you heat the air parcel, its capacity significantly increases. Now, then here, what happens if I cool it down? If, let's say, I provide a kind of a cooling. So if I were to provide a kind of a cooling activity, here, its volume will reduce. Not only the volume, the particles will come much closer to each other, isn't it? The particles will be coming much closer to each other. So, what can we say with regards to the moisture carrying capacity? Can we not say that the carrying capacity of the air parcel has now reduced? After heating, the carrying capacity had increased because the spacing had increased. Now, can we not say that moisture carrying capacity reduces? We can make that assumption, isn't it? Now, that is how, with the change of temperature in many areas, the humidity conditions they end up changing. Now, here, before we go on into the intricacies of it, I want you to be able to relate it to one or the other instance in your life. And all of us would have experienced the impact of humidity. For example, those of you living in coastal areas, or if any of you go to visit a coastal area, you will find that it is not very hot. The temperature is not absolutely as hot as you will find maybe in Delhi, maybe in Rajasthan, maybe in Punjab. So that high temperature, 45, 46 degree, that high temperature you won't observe in the coastal area. But the conditions will be very intolerable, oppressive as it is referred to. Why? Because when you start sweating, that sweat will not evaporate. Under normal conditions, when the body starts to sweat, the prime purpose is that when the sweat will evaporate, it will provide cooling to the body, thereby maintaining the temperature regulation. But then, when the sweat does not evaporate, at that point of time, you start getting or you start feeling uneasy. There is loss of fluids from your body, there is no cooling, and many of the times you feel giddy and you tend to faint as well. But simultaneously, if you go to, let's say, Chandigarh or Ambala or Jalandhar or any of these areas, temperature is very high. But even if you sweat, it will immediately evaporate. So there is not that amount of discomfort in many of the cases. That is controlled by humidity. The air parcel, if it has got the capacity to take in more water vapor, so all your sweat will evaporate and you will feel the cooling process. But if the air parcel is already not having any more capacity to include any more vapor, then whatever you generate as liquid, it will never evaporate. And that is when you start feeling clumsy, uneasy, and giddy. So that is where humidity has a direct impact on our day-to-day lives as well. When the air is very dry around us, for example, recently you would have come across the news story that the air in Bangalore is so dry that people have started experiencing static shocks. That when they touch anything, there is a kind of a static shock which they receive. You would have heard about that news story. So that is because the air in Bangalore is very, very dry. It is even lesser than the average humidity required for the better maintenance of the human body. So when the air is very dry, not only will the plants they start to dry and die out, but also your skin becomes very dry, it starts peeling off in certain areas, and that is where you have the ill effects which are experienced. So that is the impact of humidity. Now, humidity, we know that water carrying capacity of an air parcel varies with the temperature of the air. Warmer air parcel can hold more amount of vapor as compared to a colder air parcel. In other words, the moisture carrying capacity of air increases when it is heated up, and moisture carrying capacity of air decreases when it is cooled down. So when we say moisture carrying capacity, it increases when there is warming of air, and it decreases when there is cooling of air. Now, this is the general principle or the general phenomena. Now, here, if we talk about it, if we talk about the planet here, planet Earth. Now, in this case, if I consider, if I have to give the generalistic solution to someone, now the temperature is higher at equator and the temperature is very, very low at the region of the poles. The poles, the temperature is so low that vapor will not exist. It, whatever water will exist, it will exist in solid state only, right? So, can we not say that as we move from equator to the poles, what happens to the carrying capacity? As one moves from equator to the poles in general, on an average, what happens to the carrying capacity? Beautiful. It reduces. Carrying capacity reduces. So as you move from equator to poles, the carrying capacity will indicate a reduction. Now, if every other condition is uniform in any area, let's say if I am comparing this area A, let's say the ground conditions etc. at A and the ground conditions etc. at B, in terms of availability of liquid water etc., everything is similar. If the carrying capacity reduces, what can we say about the water vapor which is present or the moisture availability? We can also say that in general, as we move from equator to the poles, if everything else is constant or everything else is uniform, there is a general reduction in moisture presence or humidity. So that is why humidity in general, humidity in general reduces as one moves from equator to the poles. Why? Because there is a reduction in carrying capacity. There is a kind of a reduction in carrying capacity. That is why. That is why you will experience that there is a kind of reduction in humidity, associated change in humidity, which is experienced as well. Now, the types of humidity. So, this humidity that is measured, that is the amount of water vapor in the atmosphere, that is measured in various different types, various different units. Okay. So, when we talk about types of humidity, Depending upon how you are able to measure that, that is where it leads to different types of units. For example, when we say, so types of humidity can broadly be categorized into three types. That is, you have absolute humidity. Absolute humidity, this is just a measurement. How do you measure it? Okay. Specific humidity and relative humidity. In general, okay, that is what I have written, guys. I hope there is no issue in this one. Last slide. Humidity in general reduces as one moves from equator to the poles. Anyone having any issue in that? Suraj. Suraj, humidity reduces as one moves from equator to the poles. It does not increase. Why will the humidity increase as one moves from equator to the poles? In general, I am talking about the measure of the absolute humidity will come at. Okay. Yes, I understand, Suraj. Have some patience. We'll come to that. Now, Biswajit, being near to sea will lead to have water vapor. Yes. And Bhavani, can we say that when we move from equator to southern hemisphere, the moisture increases since during winter season at northern hemisphere there's summer season? Uh, Bhavani, can we say that when we move from equator to southern, see, after equator, you will directly go to southern hemisphere itself, right? So you are saying that when we go from equator to south pole, the moisture increases. The carrying capacity increases, Bhavani. Yes, you can say so. Um, Anil, that is correct. Shruti, no. Okay. So these are your different types of humidity which is present. Let us take a look at each one of them. And I will take you back to the previous slide as well for the aspect of the humidity reduction from equator to the pole. So don't worry. When we talk about absolute humidity is what? In this, in any air parcel, you measure the amount of water vapor which is present. So the amount of water vapor in grams, the weight of the water vapor per volume of the air parcel you are considering. So if there is air present in any region, this is your air. Okay. And here, if I consider any air parcel, if I have to measure the humidity which is present in the air, I can basically measure any sample of air. From one sample of air, I can get an idea. So I take this sample, I measure it out, and I find it has got a volume of 1 meter cube as a sample. That is the volume of air. So I will measure what is the weight of water vapor present in that air sample. That is something which is going to fetch to me the figure of absolute humidity. So absolute humidity is the weight of the moisture content per volume of air at any given temperature. Okay, expressed in gram per meter cube because it is weight by volume. That is where weight will have its units in grams, volume in meter cube. That is the unit of absolute humidity. Absolute humidity in general decreases from equator to the poles. The humidity decreases from equator to the poles. Why? Because eventually at the region of poles, what do you think will be the amount of water vapor present in the air at the region of the poles? In the region of the poles, you will find that there is absolutely minimal amount of water vapor present, almost negligible. Why? Because the temperature is so low that water won't be able to exist in a gaseous state anymore. Water will condense into ice particles, it will fall on the ground. That is why the air above the poles is very, very dry in general. That is why you will come across a scenario that when we talk about absolute humidity at the region of the poles, it is absolutely very low, very, very minimal. Whereas at the region of equator, because of higher temperature, you have a greater carrying capacity at the same time. You have the availability of moisture which is picked up due to rainfall activities, due to nearby water bodies. That is why around the lower latitudes, generally, in general, you'll find higher amount of humidity. Okay? Biswajit, which is the one that you could not get? Kindly tell me, my dear friend. And Cherrapunji, Siddhant, Cherrapunji doesn't have a sea nearby. Then why it is so humid? That is because of the moisture carrying. So it is that which causes so much rainfall. The winds which keep on coming in Cherrapunji. Um, when this topic over, then Yogita, then take questions on this topic of previous. Okay. Devansh, why Bangalore experiences dry air even it is closer to coastal region? Bangalore is not closer to coastal region, my dear friend. Please don't get under the misconception that Bangalore is closer to the coastal region. And if you feel that it is closer, then recalibrate what you understand by close and far. When we say is the audio available, my dear friends? Audio is available? Thank you. So basically, is the audio available? Everybody, please tell me, is the audio available? Good. Okay. Yes, I will repeat the Bangalore part. Wire is loose. As long as the wire is loose only for the electronic devices, I think we should be fine. Right? So, audio is perfect. Before talking about Bangalore once more, I will have to check the digital aspect. Let me know if the audio gets imperfect any further. Okay. So, Bangalore receives higher rainfall because of winds coming from the Arabian Sea. But please understand, it's humidity that you experience in Bangalore, in the region of Mysore. It has got nothing to do with the coastal area. If we consider the humidity in the coastal area, it is only immediately at the coastline. For example, if you consider, let's suppose any coastal area that you consider, let's say Chennai, or let's consider in Odisha, let's consider the coastal area of Puri. Puri is having a coastline. But if you move slightly inwards in the region around Bhubaneswar and so on, where you move away from coastline, the impact of coast on humidity, that will start to disappear there. Bangalore is already 500 plus kilometers away from the coastline. So the coastline will have no impact on humidity in Bangalore. All that the coastline can do is bring rainfall. And that too, ideally, Bangalore should not have received rainfall because of its location. It is only because there is a gap in existence in the region of the Western Ghats through which the winds, they find a channel and they flow through. That is why they bring rains. Now, for the question that why the air in Bangalore is so dry, the answer is due to consistent movement of the winds. Bangalore is one of those areas which is present at a slightly smaller altitude, but you have the consistent movement of the winds. Now, if these winds, they carry moisture, fair enough. But in most of the cases, that is only in the rainy season will you observe that these winds are carrying moisture. In rest of the year, the region around Bangalore will have the movement of drier winds. Drier winds in general, due to which whatever water vapor is present in the air, that water vapor is also taken away. That is why Bangalore experiences very dry conditions where the humidity levels, they get to lower than 20% or even 30% in certain cases. Okay? Now, absolute humidity, again, I will repeat, absolute humidity is how you measure humidity. Specific humidity is again how you measure humidity. You will measure it by some or the other factor. So one of the methodologies of measurement is by weighing the or having and calculating the total weight of water vapor which is present in the air parcel. Air will have the presence of gases, water vapor and dust particles. So if I am able to carry out the weighing of the water vapor, I will get an idea that what is the total water vapor present. So how do you calculate that weight? So per unit volume, you calculate the weight of water vapor. Any sample size that you take one sample size of volume, unit volume, and you are able to calculate what is the content or the amount of water vapor present. And that is how you are able to arrive at absolute humidity. So that is where you have the factor of absolute humidity, which is weight per volume. Then we have specific humidity. Specific humidity also is used only to measure the water vapor present in the air, right? Or the humidity content in the air. But in this case, the measurement is done in a different manner. In the earlier case, we considered one unit volume of air as our sample size. In this case, we consider one unit weight of air. So we carry out the experiment or the weightage right. So here we ensure in the case of specific humidity that this air sample that we are measuring, that air sample has got a unit weight of 1 kg. It has got a unit weight of 1 kg, right? And in that unit weight of 1 kg, we measure what is the weight of water vapor present there. We measure what is the unit of or what is the weight of water vapor present there. So that is where we get the unit of specific humidity. So mass of water vapor per kilogram of air, that is what is specific humidity. In the earlier case, what was there? Mass of moisture per volume of air. Now it is per kilogram of air, right? So even if there is a slight expansion of air in general, let's suppose air parcel expands ever so slightly, the expansion is led by the molecules, the particles of the air. So if I give you an example, if I give you a scenario, let me take you to an earlier slide. If I give you a scenario that this represents 1 kg of air, 1 kg. And how do I know 1 kg? Based upon the weight of the air particles which are present, right? Molecules, etc., dust particles, etc. Now, when I heat this up, and that is what we have been studying till now, when I heat this up, the air will expand, isn't it? The air will tend to expand. But what about the weight? What do you think will happen to the weight? Will the weight also increase or decrease? No, the weight will remain the same, right? Because all the molecules who exert that weight, they have moved away. They have created the space, right? So that is why when you measure specific humidity, in specific humidity, by the way, you are measuring the weight of the water vapor and with respect to the weight of the air parcel. And there, what will be the unit? Weight of water vapor in grams, weight of moisture, weight of air parcel or the unit of air is also in grams or kgs. Let's assume grams. So that is why specific humidity will not have any unit which is prevalent, no unit. So here, that is why when you measure specific humidity, it is largely consistent and does not change with the change of volume or temperature, right? So seldom affected by change in volume or temperature. Why? Because even if you heat it up, now in the earlier scenario, let's assume that there were certain air particle or certain water vapor particles which were present here. Okay, let's assume that the weight of the water vapor was 5 grams. Let's assume. Now, as the air has expanded due to warming, due to heating, the air molecules are the ones which have pushed the envelope from all sides. The air molecules have occupied a larger space, isn't it? So, here also you will have the presence of water vapor, presence of a lot of water vapor. But unless and until there is an additional source or an extra source which is able to pump in water vapor here also they will represent what is the weight of the water vapor here as well? 5 grams, isn't it? So despite the warming which has happened, the specific humidity has remained same. So that is why, because now what about the case of absolute humidity? With the change in temperature, would the absolute humidity change? It can. How? Let us understand. So, for example, if I give you a scenario, if I give you a scenario that this is the air parcel and this is the unit volume is 1 meter cube. Now, if I consider this air parcel, let's say it has got these many water vapor molecules which are present. These many water vapor molecules which are present. So let's assume the weight of water molecules in this is 10 grams. So first of all, what will be the absolute humidity? Absolute humidity will be 10 gram per meter cube. Let's say I heat it up. Now, when I heat it up, It will expand. Now, when it expands, the water vapor molecules which were present, they will also be spread out. They will also be spread out. But what is absolute humidity? Absolute humidity is the weight of the moisture per unit volume of air, right? Where volume is constant. So, if I have to measure the absolute humidity in this expanded air parcel, what will I do? I will measure it in a volume of 1 meter cube, which was present earlier. This is the sample volume I have taken. Sample volume only for measurement of absolute humidity. I have taken this sample volume of 1 meter cube. I will measure what is the weight of water vapor in this 1 meter cube, and then I will get an idea. Now, do you think that in the case A, or in the earlier scenario here, when we were measuring it prior to heating it up, 1 meter cube contained 10 grams of water vapor. Now, when you have heated it up, when you have provided that heat or that warming, now 1 meter cube, will it contain, this is 1 meter cube, the small one, will it contain 10 grams? Will it add on more, or will it have less than 10 grams of water vapor? What do you think? Beautiful. It will be reduced. It will be lesser, because that water vapor has spread out in various other areas as well. So this will have lesser vapor. As compared to the earlier situation. So that is where by heating, absolute humidity has reduced. But in the case of the earlier scenario, when you consider the specific humidity, so even if it warms up or it expands, 1 kg 1 kg of air particles will still be able to contain all that water vapor which was present from earlier. Because even if the volume is changing, 1 kg will remain 1 kg. If 500 particles made up 1 kg, it is not as if that by warming only 100 particles will weigh 1 kg. Still, you will need 500 particles to make up 1 kg. And amongst all those 500 particles, you will have the same amount of moisture which is present. That is what is specific humidity. So when we say absolute humidity, it is the weight of moisture content per volume of air. When we say specific humidity, it is the mass of water vapor per kilogram of air. That is why it is oftentimes rendered to be unitless. And specific humidity is the one which remains consistent and does not change with temperature. But then all that is the specific humidity, the absolute humidity, largely used by the climatologists and the meteorologists. The humidity measurement that you and I, we refer to mostly, that is the relative humidity. The humidity measurement that you observe appearing in the newspapers, that is where they use relative humidity. The humidity measurement in the news bulletins, if ever you have seen the weather portion of the news bulletins, I am sure that many of you, even by news bulletins, you would be surprised at who hears these. But if somehow you would have heard about the weather news as well, there also you get an idea of relative humidity. So, what do we mean and understand by relative humidity? Relative. Relative always means in comparison to something. That relatively, I am a better student. Relatively, I am unable to understand anything. Relatively, I am unable to score anything. Relatively, I might be a success. So that is relative. So, relative humidity means you are comparing it with something. Now comparing it with what? So in this case, when you measure the humidity of an air parcel anywhere, you end up measuring the moisture content in comparison to the total carrying capacity of the air, right? What is the total carrying capacity? Compare it to what is present right now. That is what will give you the relative humidity. Okay. In other words, let's suppose I, as a candidate, I have a capacity to study 14 hours, let's suppose, including the general studies, including the portions of the newspapers, optional, and then 14 hours, okay, include one class in this as well. So that is my capacity. But relative to my capacity, I'm studying only 2 hours. So relative output is 2 by 14. So here again, when we say relative humidity, this is basically in comparison to what is the total carrying capacity of the air. With regards to that, what is the present quantity? For example, it is the ratio of the amount of water vapor present in the air to what it can hold. So for example, consider the region anywhere, let's say Bangalore. This is the relative humidity of Bangalore. Bangalore, let's suppose. Now, let's suppose at any point of the year, in any month, let's suppose there is an air parcel that we are considering. Now, this air parcel at the given temperature, let's say at a temperature of 35 degrees Celsius, right? In certain conditions, let's suppose carrying capacity of moisture. Let's suppose carrying capacity is 20 grams. Now, here, that is the total carrying capacity. Then, present availability. Present availability. That is what? That is, let's suppose I consider 5 grams. So, what will be the relative humidity in this case? Relative humidity will be 5 by 20 into 100. And that will be how much? Before I get bombarded with unexpected answers, which makes me think about the entire perspective of you guys appearing for CSAT. So before that only, I'm giving the answer here. Okay, so that will be 25%. Ayushman, think about it. How can it be 40%? Think about it. Okay, so here, that is the relative humidity. Now, this relative humidity, obviously, in the same day, it can change multiple times. It can bring about a change multiple times. It changes when you heat the air, and this relative humidity also experiences a change when you cool down the air parcel. So if I consider an air parcel, let's suppose, now let's say the temperature is 35 degrees Celsius. Let's suppose at 35 degrees Celsius, carrying capacity, which I will write by Cc. Cc is carrying capacity. So let's suppose the carrying capacity is 20 grams. And let's suppose available moisture is 5 grams. So what will be the relative humidity in this case? relative humidity will be how much? Good. 25. 25%. That means whatever is the total capacity, the air right now is consisting of only 25% of all that vapor. Now suppose I heat it up. There's heating which happens. During the day, there is going to be significant amount of heating, which let's suppose happens. Now, in that case, as the temperature increases to, let's say, 44 degrees Celsius, now the carrying capacity, with the increase in temperature, the carrying capacity increases or reduces? Good. It can it increase or reduce? It will increase. So let's suppose the carrying capacity increases now to 25 grams, right? And the available moisture is still the same because there is no external source. If I assume that there is no fresh rainfall which has happened, there is no external source which has added moisture into the air. So available moisture is still around 5 grams. So what is the relative humidity now? Good. It is 5 by 25 into 100. That comes about 20%. So what do you notice here? Other than your mathematical skills, which you would be very proud of, other than that, what is the other thing that you notice here? You would notice that an air which has got a particular relative humidity, if you heat it up, that relative humidity reduces. So can I not write relative humidity tends to reduce with warming? Okay. Conversely, let's suppose in this region, I cool down the air. And by cooling, obviously the carrying capacity of the air parcel will reduce. So let's say I've cooled it down to a temperature of 15 degrees Celsius. That is significant amount of cooling, around 20 degrees Celsius of cooling. Let's suppose the carrying capacity has reduced to 10 grams. And available moisture is 5 grams. So what will be the relative humidity in this case? 50%. So basically, in any place, if there is a cooling which happens, relative humidity tends to increase. Humidity tends to increase with what? With cooling. Isn't it? That is something we can easily say, that it tends to increase with cooling. So that is how we get the aspect of relative humidity. Now, again, I will give you the example of a coastal area and a region which is present in the interior. Now, when you feel that you are sweating, you are perspiring, especially during the rainy season, anywhere in the country that you are, during the rainy season, I hope all of you would have experienced that it takes much longer for your clothes to dry out, right? Because it is raining outside, many of you, what you would have done, especially now that you are in a preparation phase, many of you would have started using your interior of the room itself to dry out the clothes. And you will find out that very quick, it is not a very quick process. The clothes, they take a longer period to dry out during the rainy season, but during the summer season, they will dry out very quickly. Why? Because in the summer season, the carrying capacity is high, availability of moisture is less, so the relative humidity is less, so the air has got a greater capacity to accommodate more moisture, so all the moisture it takes up and the air is able to accommodate it. But during the rainy season, when all around you the air has got so much of moisture already, relative humidity is already high, and that is where the air is unable to take in any further amount of moisture, due to which your clothes don't dry out. During winter season, in comparison, you would have experienced that during winter season also, it takes some greater amount of time for the clothes to dry out. Why? Because the air is cold, so there is limited carrying capacity of what is the amount of moisture that the air can hold. This relative humidity basically ends up contributing and controlling the rainfall and other factors that we experience on the ground surface. We'll come to it, we'll talk about it, we'll take a break first. So, we'll take a break of 10 minutes and then we'll be back. Okay. A confirmation regarding the audio, please, guys, if you're able to hear me out. Thank you. Okay. Rohan, water taking capacity will be less in coastal regions. Yes, that is correct, Rohan. And a correct inference to make as well. Now, few of the other questions which have been pending for some time. Uh, Shamali, is the available humidity will always be lesser than carrying capacity? It will not always be lesser. It can be equal to or less than. It will never be more than. It will mostly be equal to or less than. Uh, is it practical to measure weight without compression? No. So you do measure, Prashant, if you go into the technicalities of it. So you do measure with the help of some compression, but then there you, in a way, eliminate the factors which lead to the compression and other different interferences, and you are able to calculate the weight. Abhishek, why three ways to measure humidity? Because each of them, they give you a different idea. For example, if I tell you that as of now, the absolute humidity is 15 grams per meter cube, will you get an idea whether it is going to rain or not? No. So you need to have the relative humidity angle as well. Okay. Yes, Pranay, that is correct. Right. Okay. So now we move on to the aspect of saturation of air. When is it and where is it that we say that the air is saturated? So saturation of anything means what? Means there is no scope for any extra addition, right? Roughly, in the classes of geomorphology also, if you have an analogy to understand, or in most of the geography classes, around 8 p.m., 8:15 p.m., most of you start rising up in revolt that now nothing is going inside our brain. Now I cannot take it anymore. Just end this, isn't it? So that means your brain is now saturated, doesn't have the capacity to take anymore. Take the another case of a sponge. Now, in the sponge has the capacity to take in some water, absorb water, and if you keep the sponge near water, eventually a condition will come that it will not have the capacity to take any more water. So that is when the sponge is saturated with water. Similarly, air around us also has the capacity to take in water vapor. But after some time, the air will be able to reach its maximum capacity. Beyond that capacity, air will not be able to take any more moisture. So, the air containing moisture to its full capacity. Full capacity is what? Its carrying capacity. Carrying capacity. So, when the air has got the moisture which is equal to its carrying capacity, then we say that the air is saturated, that it cannot take any more moisture. It cannot take any more moisture. Okay. Sahil, okay. Sahil has given an answer already. So let me frame a question around it. What will be the relative humidity when we say that air is saturated? What will be the relative humidity in that case? If I say an air parcel is carrying as much moisture as the carrying capacity, relative humidity in that case is 100%. Is 100%. Because when I say that an air parcel, let us assume its carrying capacity is, let's say, 15 grams. And the available moisture is equal to the carrying capacity in the case of a saturated air is 15 grams. So what will be the relative humidity? It will be 15 by 15 into 100, and this will be 100%, isn't it? So that is when we say that the relative humidity of air is 100%. Now, here we also get an idea about what happens or what is the behavior of air with respect to temperature and how it responds accordingly. Let us take a look at it. So, for example, I consider or give you an example of an air parcel in different conditionalities. Now, let's assume in the first case, the carrying capacity, let's assume, is 20 grams. The present vapor, let's say, is 15 grams at a temperature of 35 degrees Celsius. So what will be the relative humidity in this case? Very good. 75% will be the relative humidity in this case. 15 by 20 into 100. And what happens if I cool it down? If I provide cooling to an extent where, let's say, the temperature has been reduced to 27 degrees Celsius, let's assume. Now, as the temperature reduces, the carrying capacity will also reduce. So the carrying capacity overall reduces to, let's assume, 15 grams. Present vapor which is present, vapor present is 15 grams. Right? So what will be the relative humidity in this case? It will be 100%, isn't it? So this is where we say that this is saturated air. Why do we say it is saturated air? Because look at it. Whatever is the carrying capacity, that much the air is already containing and carrying with it. So the air has got no scope to include any more water vapor in it, right? Air has got no particular scope to include any extra water vapor. Now, for example, if I further cool it down, and I cool it down to a temperature of 20 degrees Celsius. Now, when I cool it down to a 20 degrees Celsius temperature, carrying capacity will reduce. Let's suppose the carrying capacity has reduced to 10 grams. What was the amount of vapor which was present? The amount of vapor which was present was 15 grams, isn't it? Vapor present is 15 grams. Now what will happen? All the 10 grams of carrying capacity means what? That the spacing available between the molecules can accommodate only 10 grams of vapor. This gives me an idea that spacing available between the molecules can accommodate or can adjust only 10 grams of vapor? We can say that. So those 10 grams of available vapor will be adjusted here, right? So here 10 grams will be adjusted in this air parcel, but available vapor is 15 grams. So what will happen to the extra 5 grams? So you have extra 5 grams. What will happen to that? This extra 5 grams, which does not find the space to accommodate itself due to that cooling, this extra 5 grams, they will start to condense. They will start to change their state. Now, this undergoes condensation. Undergoes condensation. Now, will it condense into solid form or solid ice particle or liquid water droplet? If this extra 5 gram is condensing, will it condense into solid ice form, ice particle, or liquid water droplets? What do you think? Apply your logic here. Look at the temperature which is present and then apply your logic. I could not give you a better hint. Beautiful. So this 5 gram will get converted into liquid droplets. Why not solid ice? Because the temperature at which all this is happening is 20 degrees Celsius. And water does not exist in ice form at 20 degrees Celsius. It exists in liquid form, and around 0 degrees Celsius or below, that is when water exists in solid form. So from this basic factor, we can have multiple different implications, all of them which help us contribute to our understanding of the weather systems across the globe. But before arriving at conclusions, what are the inferences that we can make out of it? One another aspect. When the air is saturated, relative humidity is 100%. What happens if I heat that air? If I cool it down beyond saturation, there will be condensation as we have seen. But what happens if I heat it out? Will it remain saturated? No. Its saturation will go away. It will have a capacity to further take in more amount of vapor. So saturated air, when cooled down, undergoes condensation. Saturated air, when heated, further becomes unsaturated and has the capacity to take more moisture. Okay? So, we can say cooling off air eventually leads to saturation, right? This is the first observation that we can make. The second observation, cooling off air beyond saturation leads to condensation. Now, this temperature at which condensation is happening, it can be anything. It can be 15 degrees in certain cases, it can be 0 degree in certain cases, it can even be -4, -3, -2. So depending upon at which temperature condensation is happening, you will have a resultant as liquid droplet or ice particle. If let's say this cooling and this condensation is happening at -2 degrees Celsius, you will not find liquid water droplets as condensates. Rather, you will be finding what? Ice particles. Okay. So at what temperature does the air reach saturation? Which factor will determine that? That at what temperature air will reach saturation? What do you think? What is the factor which will determine that? It is the available humidity. The available humidity levels determine that what temperature will the air reach saturation. How? Let me tell you. Before that, available levels of humidity determine the temperature at which saturation is reached. How? So again, I give you certain examples. I hope this is the portion that I can erase. Now, I have an air parcel. Okay, two air parcels, let's suppose. In one case, I have the relative humidity. Let's say I am in one of the most humid places in the country, maybe Kolkata, maybe Chennai. Let's assume I'm in Kolkata. And the relative humidity is there is 85%. Temperature is 35 degrees Celsius. Okay. Means there is 15% more capacity to the air. Now, if I go to Leh and Ladakh, air is very dry, no source of moisture in Leh and Ladakh region, isn't it? That is why cold desert also it is referred to in certain cases. So if I go to Leh and Ladakh, and there I find out that because the air is so dry, relative humidity, let's say, is 40%. And temperature is, or rather than Leh and Ladakh, let us take for comparison sakes an area which has got similar temperature as Kolkata. Let's take the case of the national capital, that is Delhi. Let's say I take this as Kolkata. Let's take Delhi. Delhi also has dry air. Delhi, Chandigarh, all these areas, they have dry air. So the temperature here also is 35. Now, both the air is unsaturated, right? Both these air parcels are unsaturated. And observe this carefully, guys. If you understand this, you'll be able to understand dew formation, you'll be able to understand fog formation, you'll be able to understand cloud formation, occurrence of rainfall. Everything is related to this basic concept. Okay, so understand this carefully. So here, when we say that relative humidity in Kolkata is 85% at 35 degrees Celsius, if I cool it down by 10 degrees Celsius, at night, sometimes the temperature drops by 10 degrees Celsius, right? So if the temperature is lost by 10 degrees Celsius, I can have the condition where the relative humidity attains 100% by, and here temperature is 25 degrees Celsius. So in 10 degrees Celsius drop, the air has reached saturation over Kolkata. But will the same be observed over Delhi? No. If I reduce it by 10 degrees Celsius, if I reduce the temperature by 10 degrees Celsius, let's assume, and the temperature in this is 25 degrees C, relative humidity will increase after cooling. So relative humidity maybe comes out to be 80%. Further cooling has to be initiated. So let's say I further cool it down. I further bring down the temperature to 5 degrees Celsius. That is when it reaches, let's say, saturation. Now, in both these cases, the initial temperature was consistent, but the temperature at which saturation occurred, that was different. In the case of Kolkata, very quickly saturation was attained because already the relative humidity was 85%. In the case of Delhi, the saturation was attained much later because the relative humidity was only a meager 40%. So that is why available levels of humidity, they determine the temperature at which the saturation is reached. With the air having a greater humidity levels, they are able to reach saturation faster. And the air which is in drier regions, which has lesser humidity, they are able to reach saturation much later. And again, if the air reaches saturation and is cooled down beyond that, what happens? Condensation happens. That is when you observe the formation of dew, formation of cloud, formation of fog. All of that happens when the air saturates and cools down further. So we start with the process of condensation. Condensation, something that you all would be aware of, that what is condensation. Not because this is a level of graduation level science or an engineering level science. This is a basic science. Maybe up till class 5th or 6th, you would have known what do we mean by condensation. Any one of us who is not aware of this? Nonetheless, even if you are not aware of it, just understand condensation is when you have the gaseous particle, they get converted into a liquid particle due to the reduction of temperature, or a liquid gets converted into an ice particle again due to cooling. So because of cooling, there is a change of state from gaseous to liquid, liquid to solid. That is what is condensation. So small drops of water which form when warm water vapor or steam, when it touches the cold surfaces, that is condensation. The easiest manifestation of condensation is, or easiest view of condensation that you can have, is by opening up your fridge, refrigerator. As simple as that. Open up your refrigerator. Take out any utensil which has been in refrigerator, or take out a bottle of water which is in the refrigerator. Put it on the table, right? Let it lie there on the table. Let's say you have taken a bottle of water and you have put it on table. After some time, you would have observed that there is development of small droplets of water on the outside of the bottle. Most of you would have observed that that is when the water starts accumulating on the table as well, right? Most of you would have observed that. Now, where does this water droplet come from? The water droplet that you see on the outside of your water bottle, where does it come from? Have you ever thought about it, that what is the source of this water droplet? All these droplets, we basically interact with them on a daily basis. Does that droplet come inside from the bottle? It penetrates the glass and gets outside. Is that droplet because of what you breathe in, breathe out? Is there a kind of a grand design by God Himself creating the droplets on the water bottle? Or is it because of condensation which is happening of the air outside? So, all these droplets, that is basically the condensation of water vapor happening from the air parcel outside. How? So, again, understand this. When you have the water bottle which is kept in the refrigerator, its temperature might be very low. Its temperature might be 0 degrees Celsius, 1 degree Celsius, or 2 degrees Celsius. Let's say 2 degrees Celsius. And if you have never observed these basic nuances till now, it is high time in your life that you observe it. What I want you to do is take a bottle of water, keep it in the fridge for some time, right? For some considerable duration. And when it is completely chilled, take it out and keep it on the table. Now, after you keep it outside on the table, leave it for a couple of seconds, and with the other hand or the other palm of your hand which has not been cooled down by touching the bottle, try to put your palm closer to the bottle. As you move closer to the bottle, you will experience a slight coolness in the air with the palm. You will experience that the air becomes cooler as you near down to the bottle surface. So what does that mean? That means the surface of the bottle cools down. The air in contact, right? So the air reaches saturation, and even after attaining saturation, the air is further cooled down. Air is cooled further. And what happens when the air is cooled beyond saturation? It leads to condensation. Now, here you can try out various things. Given that we are in this month of the year, that is the month of March, many areas are particularly dry right now. There is a lot of hot temperature which is present, lack of rainfall in many parts, major parts of the country. Most of you, wherever you are living in right now, other than few places in the eastern part of the country, most of you would be experiencing very dry conditions, isn't it? 1 or 2 days there will be rainfall still in the northwestern and the region around Delhi NCR. There will still be heavy rainfall one or the other days, but in general, on an average, other than the people belonging from West Bengal, from the region of Assam, Mizoram, Meghalaya, and also Jharkhand and Odisha. Other than that, rest of you all will vouch for it that the country is right now experiencing dry weather. Now, do this thing right now. That is in these times when the air around you is very dry. Observe how much time does it take for the formation of water droplets. If ever you have analyzed the formation of water droplets, immediately after some time you will observe the small droplets to be present. But then if you are, let's say, away from the coastal area, if you are right now situated in Amritsar, Kapurthala, Jalandhar, or Chandigarh, Delhi, Lucknow, Patna, Bhopal, Indore, Jaipur, any of these areas which are away from the coastline, you will observe that it, even though when you place it outside, the bottle develops a kind of a haze of sorts, but then the droplet formation takes some time, maybe 5 minutes, maybe 3 minutes, but it takes some time. Now repeat the same process in the rainy season when the rains come in. When the rains come in, when you do the same process, immediately you will observe that droplets, they start accumulating, and there's a lot of droplet which accumulates. And why is that? Because in the rainy season, the air around you is automatically much more humid as compared to the present day condition. So that is how, and again, this will vary. If right now you are in Jaipur and you want to visit, let's say, Mumbai, there again, the time taken for the droplets to form will change when compared to Jaipur to Mumbai, because the air humidity or the moisture in the air, that is lesser in Jaipur as compared to Mumbai, because Mumbai is a coastal area. So that is how condensation happens. Okay. So broadly, we can say condensation condensation is initiated after the air is cooled beyond the point of saturation of saturation. Now, if I give you the statement that this condensation will be initiated only above freezing point, that is above 0 degrees Celsius, will it be correct or incorrect? What do you think? If I say that this condensation will be initiated only above freezing point, correct or incorrect? Arindam, what do you think? Will it be correct or incorrect? It is incorrect, because condensation can happen even below freezing point. It might be possible that the saturation is reached even lower than the freezing point. Then the condensation which will happen, that will be what? It will be, in a way, the presence of the ice particles which will happen as condensates. So that is how you have the condensation which happens. Okay. Boiling point. No. I'm saying freezing point. Okay, please ask your question, Arindam, rather than the long grievances that I'm seeing. Please ask your question. What is your question? Let me know immediately. And Pranay, explain once. What is it that you want to be explained, Pranay, again? Gagan, carrying capacity in Kolkata and Delhi will be the same for 35? No, they will never be the same. Kolkata is a coastal area, Gagan. So always the amount of humidity will be greater, and sometimes, yes, it can have the same carrying capacity depending upon the local topography as well. So yes, it can have. Apologies for that, Gagan. So your question is, I have asked that, is steam making is a formation of condensation? No, absolutely not. Steam is what? Steam is the gaseous form of water. So steam is again water vapor, nothing else. Okay? Steam is water vapor. Okay? Anything else that has remained unanswered due to which there was such a long grievance? Please let me know. And again, I would like to repeat, maybe for the 100th time, guys, if for some reason the SMEs are taking some time to get back to you, please don't lose your patience. Please don't think that it is a larger conspiracy where the United States and us, we are conspiring to ensure that you don't succeed. There is no larger conspiracy behind this. We want to have the answer for all of you. That is the purpose. Ideally, I would have taken all the questions and have not taught anything, but that would not help you at all. So that is why I am putting more focus on looking at the basic concepts. You will not find the concepts to this level in any textbook, and that is a guarantee that I can give you. Open up any textbook to the market, you will not find the explanation or understanding of the portion of humidity from the level of particles. So that is what we are endeavoring, we are trying to. Okay. In the meanwhile, if any question is left unanswered, have patience. Still, if it is unanswered, write to us, write to me. I will give you my mail ID. Write to me, but please don't turn out to be those angry birds that you see, right? That this is a conspiracy, nobody is answering to my question, maybe you don't want me to succeed, etc., etc. You can write a mail to me in case your queries are unanswered. But few of you also have the habit, where while I was replying to the mail, few of you also have the habit that while you are typing a question here, simultaneously you are sending a mail with the same question as well. Don't do that. Wait till the end of the class. Whatever questions they persist till the end of the class, send it to me. Okay? Right. Uh, Samin, steam makes droplets on my face. So, steam makes droplets on your face because steam gets in contact with the colder surface of your face, the colder skin of your face. So, whatever water vapor which was present in the steam, by getting in contact with that colder temperature, that is where it undergoes condensation. Okay. Vijay, as the bottle in the room temperature, the saturation is in liquid form. Yes, always, Vijay. That is correct. Uh, Sarthak, 0 degree temperature carrying capacity. It depends, Sarthak. It depends upon the air in the region. It depends on the temperature of the preceding hours, the temperature of the following hours. So it is dependent on many factors. Okay, right? Now, again, I will talk about the condensation which is happening. Condensation always happens when there is a temperature cool down beyond the saturation temperature. After the saturation is reached, at the point of saturation, that is when the relative humidity becomes 100%. That is when it is at its maximum carrying capacity. If you further cool down the air, only then will you have the extra particles which will start to condense. So condensation is always initiated after the air is cooled beyond the point of saturation. Now here you also have to understand, once the relative humidity reaches 100%, why we need to cool again? Okay, that is the doubt. Okay, now I understand where the doubt is coming from. Okay, so the question is that once the relative humidity reaches 100%, why we need to cool again? So my counter question is, why do you need to cool to make the relative humidity reach 100%? Has the government of India initiated a program that I am unaware of, that every one of you cool the air till it reaches a relative humidity of 100%? No. It is the general process of heating and cooling during which the air happens to attain a relative humidity of 100%. And if the general trend of cooling goes beyond that, and when the air has already reached saturation, then what will happen? If let's suppose, so please understand, for all this heating and cooling that is happening, if you are getting a conception that we humans, we mere mortals have the capacity of impacting the humidity of the entire air, you are overestimating our capacity. We don't have that capacity. We don't have the capacity to provide heating and cooling to the entire air. It is the natural thing which happens. It is a natural process that we are trying to understand. Okay, so for example, if you have day temperature, daytime temperature, again I will take the case of Kolkata only. Kolkata. So daytime temperature in Kolkata, any of you belonging from Kolkata, let me know what is the daytime temperature nowadays. What is present as the daytime temperature? Now, what happens when we go at night time? Night time. So daytime temperature, let's say, is 30 degrees Celsius. Okay. Now this daytime temperature at 30 degrees Celsius, let us assume that you have a relative humidity at this point as 90%. Nighttime temperature, as has been informed by one of you, Nighttime temperature, let's assume, is 18 degrees Celsius. Right? Now, relative humidity is already 90%. So even if I cool it down by 5% or 5 degrees, if I take the temperature to 25 degrees Celsius, it might be possible that it gains a relative humidity of 100%. So even by that 5-degree cooling, the relative humidity has already been attained, which is 100%. But nighttime temperature is 18 degrees Celsius. So there is a reduction of how much? 12 degrees Celsius. And we are not doing so. It is not the government of India or the government of West Bengal or you and I who have the capacity to, okay, but 18 degrees, see, I don't like, 17 is my lucky number. So today the nighttime temperature should be 17 degrees. That is not how the temperature works. It is an automatic process. So here, after it has reached the relative humidity of 100% at 25 degrees Celsius only, nighttime temperature, when further reduces to 18 degrees Celsius, what do you think is going to happen? There is going to be condensation, right? So that is where the condensation happens. Now, conversely, think about a situation where this relative humidity is now here 18 degrees Celsius, means condensation will happen. Now, how will this condensation happen? It is 18 degrees Celsius. So do you think that suddenly the air around you will get converted into raindrops and it will start dropping on the ground? It will drench you? No. How do you think this condensation will happen? Where do you think this condensation will happen? So this condensation will be accumulated in the form of droplets of water. Droplets of water which will accumulate on the ground surface and any surface which is cooler. So in this case, you will form accumulated droplets, liquid droplets on ground surface, grasses, metals, etc. And what is it that we call this accumulated liquid water droplet as? What is it referred to? Very good, Kivika and Pranay. It is referred to what we know as dew. This is what we know as dew. So on the blades of the grasses that you observe the accumulation of these droplets, these are basically the condensates, the moisture which has condensed into liquid droplets. So the tiny drops of water that form on cool surfaces at night when atmospheric vapor condenses. Now, the dew point is the temperature that the air needs to be cooled in order to achieve a relative humidity of 100% for the air to be saturated. So when there is cooling beyond the dew point temperature, that is when the dew starts accumulating. So cooling beyond dew point temperature is needed. Okay? Beyond that dew point temperature, when there is cooling, only then dew will be formed. So again, I take you back to the Delhi-Kolkata example. Why I am twisting it in various aspects and explaining again and again is UPSC asks you a question with this practical example. That is where your thinking needs to be on point all the time. So let's suppose Delhi. Let's take Kolkata, the earlier example only. Now Delhi, here, if I take you back to the earlier image, Delhi had a relative humidity of 40% at a temperature of 35 degrees Celsius, whereas Kolkata had a relative humidity of 85% at a temperature of 35 degrees Celsius. Now, at 25 degrees Celsius, Kolkata's air reached saturation. So the dew point temperature in Kolkata will be 25 degrees Celsius, whereas the dew point temperature in Delhi is 5 degrees Celsius because the air in Delhi is dry, because it is a inland area, continental area. So just like that, drier air needs to be cooled down to a greater extent for it to be able to reach dew point temperature. So dry air always needs to be cooled down further for attaining saturation or the level of dew point temperature. Now I give you the case of, let's say, Leh Ladakh now, where the relative humidity, let's assume I give you the case of Leh and Ladakh, Leh Ladakh, where the temperature, let's assume, is 20 degrees and relative humidity is 10%. Now, if I cool it down, its relative humidity will increase. But eventually, let's say, in order for this to reach its saturation, I have cooled it down, or not I have cooled it down, but natural cooling which is happening. Let's suppose that is happening at a temperature of -5 degrees Celsius because the air is so dry. That is when the relative humidity reaches 100% at -5 degrees Celsius. So in this case, the dew point temperature is -5 degrees Celsius, isn't it? Now, if there is a reduction of temperature even slightly more, even by 1 degree Celsius, there will be condensation. But this condensation will happen in solid or liquid. Liquid droplets will accumulate on the ground surface, or solid ice will develop on the ground surface. What do you think? Very simple. Solid, right? Because what do you observe here? You observe that the temperature needed to attain saturation is in negative, below the freezing point. So here, after saturation, you will not observe the formation of dew. But in fact, on all the metal surfaces, you will observe a very thin layer of ice which develops. On the ground surfaces, you will observe a very thin film of ice which develops. And that is referred to as frost. That is what we refer to as frost. Okay, so that is how the condensation does take place. Now, when we talk about clouds, what are clouds? What do we understand and what do we mean by clouds? So, clouds that we see up in the sky, they are nothing but a resultant of this process of condensation which is happening. It is this condensation of the water vapor which is happening, that is what is leading to the formation of clouds. Now, how is it that this condensation is happening? So, understand this. Okay, frost. Okay, let me write about frost. How many of you have doubt in frost? What do we mean by frost? See, here when we say dew, what is dew? Tiny drops of water, liquid water. Most of you would have encountered what is dew, especially in the coastal areas. Those of you who are living, every evening you would have observed that the grass starts to get wet, right? That the surfaces, they develop water droplets. And for the rest of you, during the winter season, at winter nights, you would have observed development of these tiny droplets. So the droplets of liquid water that develops, that is dew. Now, when will it develop? When the air is cooled down beyond the point of saturation. But the point of saturation need not be above 0 degrees Celsius. If the air is very dry in a region, it can happen that the point of saturation is in negative, isn't it? So the dew point temperature is negative in itself. So if the point of saturation, or if the saturation temperature is below freezing point, condensation which follows develops thin film of ice solid ice. That is what is referred to as a frost. Okay. Now we were seeing that how clouds are created as a result of condensation. So here, suppose I consider a particular air parcel. Now let's suppose this air parcel is warm. So it will rise up. It will always rise up. When it rises up, what will happen to the temperature? Temperature reduces because there is expansion as well. So there will be a greater reduction in temperature. As it further rises up, eventually it will reach the saturation temperature. Saturation temperature. Now, if it rises up slightly further, there will be further reduction in temperature, and that is when condensation will happen, lead to formation of clouds. So they are formed, clouds are created when the rising parcel of air or the rising column of air cools down, loses temperature, reaches saturation and cools down further. That is when condensates are formed. Vapor which is present, that forms clouds. So this is formed when you have rising air parcel cools down, reaches saturation, and undergoes condensation. Okay, so here, if I consider this to be the ground surface, if I consider this to be the ground surface, now here, when you have the rising air, eventually the rising air will be losing its temperature. And on top of it, at the air in the region of troposphere itself, you will have the presence of small dust particles as well. Now, these dust particles, remember the sixth module that we had talked about? We had said that these dust particles, they provide that surface for condensation to take place. So, the dust particles provide the surface for condensation. Particles provide the surface. And what are they referred to as? For condensation. They are referred to as the condensation nuclei or hygroscopic nuclei. Now, around these dust particles, you will observe that the condensation is initiated. Slowly and steadily, the droplets, they will start condensing around these dust particles. Very slowly and steadily, they will start to undertake a condensation around these dust particles. Eventually, you will find that all of them have gotten together and led to the formation of a larger cloud. Now, it can also happen that this condensation has happened below freezing point. So all of this will be in the form of small ice particles. It can also happen that the condensation has happened above freezing point. So you will have super cool liquid droplets, anything. Mostly you will find that at these great sites, at these great heights, you have the presence of smaller ice particles which are contained, which are present here. Okay, mostly you will find smaller ice particles. Okay. Now, slowly and steadily, these ice particles, they will grow larger in size because other water vapor around them, they will also get in touch with the ice particles, lose their temperature, reach saturation and condense. So slowly and steadily, the ice particles, they become heavier, and eventually they become so heavier that these ice particles, they will start falling. These ice particles, they will start falling. Now, when they are falling, they are going to experience the friction of air, and that increases the temperature immediately. Also, temperature closer to the ground surface is always higher than the air above. So that is why, as these ice particles are falling, they are encountering areas of higher temperature, due to which these smaller ice particles which are present, they will start melting, and you will have liquid droplets. And these liquid droplets we end up receiving as raindrops or rainfall. Okay, that is when you have liquid droplets. Now, that is how we receive rainfall. But in certain parts of the country and many parts of the world, we experience snowfall as well. In India, you experience snowfall only in certain areas, that is Jammu Kashmir, Ladakh, Himachal, Uttarakhand, and Sikkim and Arunachal. These are the only areas where you receive snowfall. Rest of the areas you don't receive snowfall in India. Now, why is it that you receive snowfall, if at all? And what is the phenomena which leads to the formation or occurrence of snowfall in these areas? So, when you have the conditions of snowfall, so that is where you have the same process which is followed. The only difference is that in these areas, ground temperature is below freezing point. Surface temperature closer to 0 degrees Celsius. That means the air above is also either lower than freezing point or close to freezing point. Now, when that happens, then these liquid droplets that you had seen, these liquid droplets which were falling, these liquid droplets, they tend to refreeze. They refreeze and they get converted into snow because of very low temperature near the ground. So liquid droplets refreeze due to very low temperature near ground. That is what leads to the formation of snow. Okay, that is why you observe the occurrence of snowfall in general. Now, then when you have clouds, these clouds, they are of various types. They are in fact classified based upon their heights as well. So all these clouds that you see, broadly, in many of these clouds, in certain cases, you will also experience thunder and lightning. Thunder and lightning. Why is it created or why is it observed? So most of the thunder and lightning that you observe, this is observed in clouds which are very thick, or that means greater vertical development. Okay, greater vertical development. There is a significant vertical profile of that cloud. So that is where these thunder and lightning happens. Why that happens? So when you have a cloud which is significantly thicker, these are the clouds which will appear darker in appearance, darkish appearance, right? What is the factor which is responsible for the cloud appearing brighter or darker? It is the type of materials which form the cloud. Is it the type of gases which are present, or is there any other factor? Hmm. Perfect, Gagan. It is the thickness. It is the thickness of the cloud which gives you the coloration. It is not the pollution. If that would have been the case, then in the region where there is no pollution, there would never have been dark clouds. It is not the factor. So the clouds that you see brighter in appearance, in certain areas darker in appearance, that is whether it allows the passage of light through it or not. A cloud which is very thick, will it allow the passage of light? No. So what is the color it will give you the appearance of? Always darker. Okay. So here, when you have a dark colored cloud, means it is vertically very developed, very, very thick. Now, in that case, the cloud is made up of many small ice particles, ice crystals, dust particles which are present. Everything, right? You have many of these. Now, these dust particles, these ice particles which are present, that means these will be rubbing against each other as well. Now, whenever objects they rub against each other, it will lead to the development of a charge. Whenever objects rub against each other, they will lead to development of a charge. So as they start rubbing against each other, there is development of charge. Right? Let's suppose there is development of charge here, that is positive, positive, and here it is negative. Charge flows from negative to positive always, so there will be a lightning. In case there is negative here, which has accumulated, ground is always considered to be zero charge. Always, ground is considered to be zero charge. So, immediately, charge will flow from negative to zero. So, you will observe a lightning strike the ground. So, majority of the lightnings that you see, majority of them, around 80% of the lightnings, they occur between the clouds themselves. Only around 20% of the lightnings, they happen between the cloud and the ground surface. So around 80% of the lightning, 80% of lightning happens between the clouds. Okay, 80% of the lightning that happens between the clouds. Now, mostly you will find that in large fields where you don't have many trees, but suddenly in between them, let's assume if there is a large field which is present, in between, let's say there is an old banyan tree or a very large tree which is present. Generally, you will come across a situation that when the lightning will strike, it will strike the tree. Why? Because tree is an extension of that zero charge of the ground. That is why the lightning falls on the buildings as well. That is why lightning influences individuals as well. So if you are an individual who saw that it is lightning, it is raining right now, let's take a shelter underneath the tree. And if the lightning strikes the tree, immediately you will be burned to death. Such high amount of charge passes through it. In one lightning strike, one individual lightning strike, voltages of close to around 11,000 to around 15,000 volts they pass in milliseconds of sort. So that is where it is always advisable that better to get drenched in rainfall than to take shelter under a tree. Never take the shelter under a tree when you have dark clouds and when there is a probability of lightning happening. Because in majority of the deaths that you see happening in India every year, in India we experience close to around 150 to 200 people, sometimes even more, losing their lives in this season. Particularly in the month of May and June, you'll find that in the region of West Bengal, in the region of Assam, in the region of Bihar, UP, Haryana, Madhya Pradesh, you'll find casualty numbers starting to be reported that lightning struck this area, 5 people died. Lightning struck this area, 2 people died. Now, it is rarely the case that an individual is walking down the road and a lightning strikes directly on that individual's head. That is rarely the case. In majority, 99% of these casualty cases, if you look into it, if you investigate into it, you'll find that most of them, in order to escape from the heavy rainfall, they had taken a shelter underneath a tree. And the lightning struck the tree, killing everyone underneath. So that is how lightning strikes happen. But then, when this lightning strike happens, a couple of seconds later, you will observe that there's a large thundering sound which follows. So, where do you get that thundering noise from? That thundering noise is basically a sudden violent explosion or an explosive expansion of air. The sound of air, as you can think about. So, this is the sound, thunder, the sound made due to sudden explosive expansion of air. Expansion of air. Where is it that the air will expand? So, if you consider the area, the region where this lightning is happening, this particular area. Now, where the lightning is happening, there will be very high amount of charge which is passing through. That high magnitude of charge in this area, there will also be significant amount of heat which will be accompanied. So this region, can we not say, air in this region experiences sudden violent heating, even for a fraction of seconds, but the temperature can rise up to even 100 degrees Celsius in these areas. There is a sudden violent heating of sorts. Now, when there is that sudden violent heating, what happens? Whenever air gets heated up, air expands suddenly. And this emits the noise that we refer to as thunder. Okay? So that is why we experience thunder and lightning. Okay? But sir, thunder happens before lightning. No, my dear friend, never. It is high time in your life that you realize or that you are exposed to this basic truth of life. Okay, that thunder always happens after lightning. And that is why I say it is high time, because I'm sure you would have lived at least a couple of decades of your life. So it is high time that you look up into the sky, you see what is happening in the sky. It is almost a simultaneous event, but then sound travels much slower as compared to light. So we are able to see the light and we are able to hear the sound later. So always thundering noise will follow lightning events. Okay. Vijay, formation of cloud is due to the process of condensation, where the air rises up, the air as it rises, it cools down. So air cools down means the water vapor present there will also cool down. Air reaches saturation, rises any further, it will lead to condensation of that water vapor and hence clouds. Okay, so that is how you have the thunder and lightning which is created. All in all, overall, we can say that the clouds, basically, they are classified into different categories. Broadly, if you take a look at this classification, you will find that there are 10 different clouds which are listed here. High level cloud, middle level cloud, low level cloud, and multi-layered cloud. And you will find, for those uninitiated in this area, you will find all these names very confusing. Cirrus, cirrocumulus, cirrostratus, altocumulus, altostratus, cumulus, stratus, stratocumulus, and cumulonimbus and nimbostratus. So it all might seem to be very Greek and Latin to you. That doesn't make any sense. So let us simplify this. How is it that the clouds are named, where they are, and what are their individual properties which are present? Dust particle. Dust particle which provides that platform around which condensation can happen. Condensation can never happen in thin air. Always it requires a platform for the condensation to happen. Okay. Now, here, clouds basically are categorized into types such as stratus and cumulus. This is the basic classification, very basic. Stratus, taken from the term strata. Strata means what? A layer. So many of the times when you step outside your house, and I gather many of you have not been observing the sky above you. So observe the sky above you. You will observe that sometimes the clouds appear in a thin layer. It is brighter, it is whitish cloud, but it is stretched over a very long area. So there you will find the presence of clouds, which is in a layered format. Layered cloud. Now, this type of a cloud is stratus. Okay. Then in certain cases, you will find clouds as heaps of cotton ball. Small accumulations you will observe. Small accumulations you will observe. These are referred to as cumulus. There's a vertical development. Okay. Now, if this portion is clear, that what is stratus, what is cumulus, rest all of them, They are basically named after the height factor. So for example, when we talk about very high altitude clouds, they are referred to as cirrus. When we talk about mid altitude clouds, they are referred to as alto. When we refer to as low altitude clouds, low level clouds, for them, you don't need any such prefix or suffix. So if there is a stratus cloud formed at a higher altitude of 10 to 11 kilometers, then you will attach the prefix cirro. So that will form cirrostratus. If there is a cumulus cloud formed at that high altitude, you name it cirrocumulus. And then you have cirrus as well. Then if these clouds are formed at the middle altitude, then you have alto, altocumulus and altostratus. When these are at lower altitudes, that is stratus, cumulus and stratocumulus. What is stratocumulus? The name in itself tells you. It will be a mixture of both. So in this case, you will find that the cloud has got the existence of a layer, but simultaneously there is a vertical development in the cloud as well. So that is what you refer to as stratocumulus. Okay? Now, rain-bearing clouds, the clouds which bring significant amount of rain, there is a word nimbus which is attached to them. Nimbus here refers to rain-bearing clouds. Rain-bearing clouds. Okay? So, you have certain clouds which spread across multiple layers. They can originate or they can be present very close to the ground surface, but they will be very thick, which might give you the appearance that this cloud is polluted, this is not clean, this cloud has not taken a shower. That is why it is appearing that. No, it is basically because of the vertical development. That huge vertical development does not allow the light to pass through, due to which the cloud will give you a darker appearance. So here is the depiction of it. See, majority of the candidates, what they will do is they will indulge in rote learning these 10 different clouds. Please don't rote learn these 10 different clouds. Try to understand by logic. How? So high altitude clouds. High altitude clouds, they are referred to as cirrus, right? Now, if there is stratus layer, layered form, then cirrostratus. If it is in cumulus form, cirrocumulus. These are so high in altitude, around 10 kilometers and above. Even if it starts to rain from here, raindrops will never reach the ground surface. That is why it is said that cirrus clouds never bring rainfall. Even if the process of condensation has happened and you have particles which have started falling, by the time that these particles will be covering 10 kilometers or 12 kilometers, by that time they will re-evaporate. So the particles will never reach the ground only. So that is how you have the cirrus clouds never bring you rain. In fact, both of these don't cause rainfall. That is why sometimes you would observe that despite the fact that there are multiple clouds that you can see, there is no rainfall. Then observe the multi-layered clouds. These can extend for kilometers in thickness. You have the multi-layered which is stretched in a layer format, nimbostratus. You have a multi-layered which extends in vertical development as an accumulation, cumulonimbus. Okay, so don't learn it, try to understand it with the logic. So cirrus clouds, basically feathery wispy formations made up of very minute ice crystals. This is your cirrus cloud. Most of you would have seen this. This is what the cirrus cloud looks like. This is what the cirrus cloud looks like. So here you will observe that there is a kind of a feathery appearance, a kind of a wispy appearance, right? These will never bring rainfall, never. When you see this kind of a cloud and you be happy that today it is going to rain, so I will be having some plans on my own, it will never rain in this condition. I will show you the clouds which bring rainfall as well. So they are often colored in bright yellow or orangish pattern at the time of sunrise and sunset because of the refraction of light which takes place. So that is why these clouds, they will give you, at the time of sunrise and sunset, you observe closer to the horizon, the clouds appear orangish, yellowish of sort. It is the cirrus cloud which lights up. Then cumulus clouds. So these appear as vertically developed clouds which resemble a heaped ball of cotton of sorts. That is the resemblance that you will see. So cumulus, that is a thick low altitude cloud. It is puffy and has got a vertical development. It is always formed wherever you have significant evaporation that is happening. That always leads to formation of cumulus clouds. Okay, these can sometimes bring rainfall, sometimes. Then you have stratus. Stratus, they are spread over a larger area, right? They are spread over a very large area, even though it appears like a worm, but I hope you understand what it represents. So this stratus cloud, if you will observe, so it is not vertically developed. So these will never cause heavy rainfall. In these, you will never observe lightning and thunder as well. In these, you will observe, sometimes you would have observed that it starts to rain very gently, very lightly. It moves with the wind, and based upon the wind pattern, again you feel few droplets of rain and again it disappears. Sometimes it rains very lightly, but there's a continuous rainfall for maybe 2 hours, 3 hours, 4 hours, very lightly so, but it rains. That is stratus cloud causing that rainfall. So they won't cause violent thunder and lightning, but they will irritate you for 3 to 4 hours continuously. Then, when we talk about actual rain-bearing clouds, the ones which bring huge amount of rainfall along with them, nimbostratus. Nimbostratus is where you have a vertical development of cloud, which is very, very thick. It might even be possible that within this you again have a cumulus kind of a cloud which is formed. So that is why in nimbostratus, if you will observe, this area will appear lighter or brighter. This area will appear darker. Isn't it? Observe this. This is a nimbostratus cloud. You will observe in certain areas it is darker, certain areas it is lighter. So this is basically the one where you will have within the clouds a lot of lightning takes place. From one cloud to the other, lot of lightning takes place. It will not hit the ground. In fact, so much lightning does not take place as compared to cumulonimbus, but some amount of lightning can happen. So in this, some lightning, very little lightning can happen. Now these clouds, whenever you see in the sky, whenever you see this kind of clouds in the sky which are spread over a large area, which have got a kind of a thickness, uniform thickness of sorts, it is going to rain for a very long time. It will not be a very heavy raindrop, it will not be a very violent rain, but it will rain for a very long time. Light rain continued for a long time. But then we have violent rainstorms as well, where you have lightning, thunderstorms, heavy movement of wind, and it rains so heavily that even the wiper blades of your vehicle, they are not enough to move away or take away the water from your windscreen. That is how heavy it rains. So those rainfall or those raindrops are created by the cumulonimbus clouds. So when we say cumulonimbus, these have a vertical development which is very significant. In many of the areas, these clouds, they will have a thickness of even 10 kilometers. Imagine the cloud in itself is 10 kilometers. So these will always cause a lot of thunder, a lot of lightning. Whenever you see these kinds of clouds, take shelter somewhere other than a tree. It is better to take shelter somewhere, or if you are in a moving vehicle, fair enough. Moving vehicle is the safest bet against thunder and lightning. But then in this, there will be very heavy rainfall, but it will stop after a couple of hours. It will give you a breathing time after a couple of hours. It is not like nimbostratus where it has started raining at 2 p.m., it will continue to rain till 5 a.m. next morning. No, that can be carried out only by nimbostratus. In this case, it will rain. It will rain very, very heavily, but it will stop after some time. So that is cumulonimbus. Okay? So these are the various different types of cloud. Okay? Now, all these are real photograph, my dear friends. Vijay, for the fourth time, I'm repeating this, and the same question I'm answering to you only. Why is or what is the role of dust particles in the cloud? Dust particles provide the surface around which condensation can take place. Condensation cannot happen in thin air. It is not as if I lower the temperature, condensation will happen in the thin air. It will require some surface. So that surface is provided by the dust particles in the upper air around which the clouds get formed. Is that clear now? Perfect. Um, okay. Now we come to the portion of cloudburst. Or we'll take it up tomorrow. Tomorrow we'll take up cloudburst, hailstorm, and then before that, this question we will solve, and then we will end the session for today. So here, which of the following statements is correct? I will give you 30 seconds. So which of the following statements is correct? Cirrus clouds are composed of ice crystals. Cirrus clouds have a flat base and appear as rising domes. Cumulus clouds are white and thin and delicate patches and give a fibrous and feathery appearance. Cumulus clouds are classified as high clouds. Okay. So here, majority of you have given the incorrect answer. The correct answer is A, that is cirrus clouds are composed of ice crystals. Anybody who has done it wrong, please let me know why did you think that A is incorrect. You might be thinking that, okay, B is correct, C is correct, but why did you count out A? You have to ask yourself. Anyways, B, cirrus clouds have a flat base and appear as rising domes. Which cloud is this? Which cloud is this one talking about? This is stratocumulus. Okay. Cumulus clouds are white and thin and form delicate patches and give a fibrous and feathery appearance. All those, all those intelligent ones who have marked C as the direct answer, that is where I want to check the level of concentration in the class as well. Right? Feathery, wispy formations made of minute ice crystal is the feature of cirrus cloud. Okay, the same words that you see that UPSC had picked directly from NCERT, white and thin form delicate patches and give a fibrous and feathery appearance. So that is where you have to think, right? cirrus. Okay. Then cumulus clouds are classified as high clouds. No, it is cirrus. Again. So that is why A is correct, rest is incorrect. Raktin, that is correct. Let me check it again, my dear friend. I did not see it, but let me check it again. Give me today's time. Okay. Then let's take a few questions. So that is where we'll end the session for today. Tomorrow we'll initiate the discussion for the remaining portions. Okay, and how rainfall? What how rainfall, Biswajit? Why strato and cumulus bring light rain? Cumulus in general, they are small appearances, small portions, so they will never bring you heavy rainfall. They will bring you very light rainfall. But if this cumulus gains a multi-layered format, that is cumulonimbus, they will give you very heavy rainfall. Okay. Why it rains always rains at evening? It not does not always rain at evening, but there's a logic to it that you will find late at night it starts raining or evening it starts raining. Why? Because there is a reduction in temperature of the air. As the air temperature reduces, it reaches saturation, cools down, brings rainfall. Binita, how did China prevented rainfall during the Beijing Summer Olympic Games in 2008? Good question, Binita. That is by the process of dispersal of cloud. So what did China do is, just like we saw the hygroscopic nuclei, you have the hydrophobic nuclei as well, which will repel water. So they used the aircraft to fly through the region where there was cloud formation, and they dispersed those particles. They spread those particles amongst those clouds. So immediately those particles, they would repel water, and the clouds, they would disappear from that region. Okay, thank you, Shivani. And lightning happens in water? No, rarely. That does not happen because water tends to move, isn't it? So accumulation of charge in any area, in in certain cases, sometimes it can happen, but generally it does not. Rishan, Risha, why sometimes rain lasts more than it is? That happens when you have a continuous and a large buildup of a nimbostratus. And that nimbostratus, if it keeps on forming, say, let's say your place is here, and here you have cloud. But let's say continuous nimbostratus is being received. So it will receive continuous rainfall. During the monsoons is when you observe this. Okay. Clouds having very large weight. No, Sachin. Clouds don't have a very large weight. In fact, if the clouds would have been so heavy, why could the aircrafts and how would the aircrafts fly from between the clouds? If ever you fly during the rainy season, you will find that the aircraft very easily they penetrate and pass through the clouds. And when they do so, you will feel that very light clinkering sound consistently on the windows of the aircraft. Very light sound of something which is colliding. Those are minute ice particles which collide with the surface of the aircraft. So all of these ice particles, they are held together, but it is not a complete solid that it will be pulled to the ground. They are very light. Thanks, Raktim. Why ground has zero charge? Because whatever charge tends to develop, that is basically then dissipated. The Gauss law comes into effect here as well, but then let's not go into that. uh, Black clouds, Manmohan, the black clouds that you see, those black clouds are nothing but very thick clouds through which light cannot pass through. See, all the clouds that you see here, from top all of them appear white because they are reflecting light. But if the same clouds you were to stand on the ground, and if you were to look at them, many of them will appear black because light is reflected. Light is not allowed to pass through. Yes, Pranay, that is correct. Yaram Seti, can't we disappear the cyclones too? No, because the occurrence of the cyclones very much controlled, the cyclones at least that we experience, very much controlled by the water temperature. And cyclone has got a lot of energy, huge amount of energy. If the energy, if you convert it, it is humongous. So that huge amount of energy you cannot control. Aman, lightning always tries to find the shortest route for the charge transfer. That is why it takes, wherever the density is there different, it takes a zigzag pattern. Why rainy season in different places with different time, Preetham? Because it depends. See, when we talk about monsoon, so monsoon reaches Kerala first, and after around month and a half, then it reaches Punjab. So if a person from Punjab says that Kerala received rainfall, I have not received, this is not fair. That is not how it works. Depends when the rain clouds reach there. Okay. Um, Sometimes I saw a dark cloud, very heavy one, but due to high pressure of air, clouds are driven away and there is no rainfall. That is when the wind movement is there. Wind movement, whenever there is very strong wind movement, and observe this, many areas across the country are receiving rainfall. If you observe a cloud formation and you observe a simultaneous movement of a strong wind, chances are it will not rain. Even if it will rain, it will rain for a short duration because the clouds will be carried away. If there is dense clouds and there is an absolute lack of air movement, that means it is going to rain very, very heavily. That is why just by sensing the air movement and looking at the clouds, you can be able to predict whether it will rain in your area or not. Okay. Uh, XY, why does ice particle melt when they fall as rainfall? That is because, see, please understand, ice particles, when they fall, they are, and this is the ground surface, they are approaching a region of higher temperature. So as they are approaching a region of higher temperature, the ice's temperature will rise. And also there is the frictional drag of the air which will increase the temperature. If any object falls from a very high altitude, it experiences the air friction and it becomes very, very hot. That is why the space vehicles, when they make the re-entry in the atmosphere, that is when the outer surface, it starts burning because of the air friction. So that air friction is experienced to some extent by the ice particle as well. That is what melts them. Okay. That is because, Sachin, thunders are observed when there is cloud. And when there is cloud, chances are there will be rain as well. That is why. Okay. So thanks, Pranay. Thanks, everyone, for the kind words and the patience. Revise this. Tomorrow we meet again. We discuss further areas and we try to discuss the portion of cyclones and cyclonic circulations as well. Take care of yourself. Thank you. Goodbye and have a good night.